Hello?
Hey, Wendy, how you doing?
I'm good. How are you?
Doing good. Sorry about that, guys.
You're good.
All right. I'm just gonna invite everybody else to see if they can join up. Just a sec. Okay.
Did you have Monday, Jeremy?
What was that?
Did you have Monday off
Do I have Monday off?
yesterday?
Yesterday? Yeah, I do. I do have Monday off. Yeah, I do.
No, I mean like I don't know how it works there.
No, I was just late this time. That's my bad.
No, did you have a holiday yesterday?
Yeah, I did. Yeah, I had Monday off. Yeah.
Okay.
Yep, that was right. For sure. Did you guys get a holiday or?
Yep. President's Day.
Nice.
Did you have Queen's Day?
They call it Family Day. So it just it was initiated as a holiday in 2008, just by one of our prime ministers. So, but before that, we had no holiday. So it was completely, we just go to work.
Sounds good.
For sure. All right. I'm just trying to see if I can find those two guys' email addresses. But if you guys want to, you guys can actually start the quiz if you want. I just have to figure out these guys. How about for you, Clinton? Did you get a holiday, my man?
I did, yeah.
Nice. Way cool, man.
I know. I'm just don't really want to.
All right.
Did you find his email address?
Him? Yeah, I did.
Okay.
Just send it to him right now. I'm just hoping that he joins. But man, dang. But next time, guys, if I end up being late, you guys should just start without me.
Well, we don't know how to spell it.
What was that?
We don't know how to spell it.
Oh, dang. Okay. Well, I'm glad to help you out with that. All right. Hey, what's up, Kim?
Hey, how are you?
Doing good. I apologize for being late.
No, it's okay.
That is my bad. But hey, if any of you guys figure out how to do it, you guys just go on without me next time, for sure. All right. Well, I guess what would you guys like to start off with?
We can go to the quiz.
Yeah. Sure. Yeah, we're kind of limit for time. All right. I guess I'll just start off with basically going through the quiz then, for sure. All right. Okay. I just opened mine right now. So I guess we could start with the very first question, which is question number 3. And I guess I'll just start us off, guys. All right, so it says, suppose we have a set of paired data and let D equals XA after take away X before. The null hypotenuse equals 0. The alternative hypotenuse equals 0. And the population standard deviation is not known. Jordan collects a sample size of n equals, 9 and computes the sample as 2.2 and a standard deviation of 3.3. What is the value of the test statistic? So I believe for this one, you'd use the equation. So it would be T equals D, which is 2.2, take away the hypotenuse, which is 0, divided by 33.
3.3 or 33?
Yep, that's right.
Okay.
And then have the 9. All right. So 3.3. 3.3. All right. So I got 2. What did you guys get?
2.
2? Awesome.
2.
Legit. Way cool. And Stalin, you're here, eh, man?
Yeah, man.
Awesome. Way cool. Welcome, man. Welcome. All right. So now we're going to go to question number 3. And who would like to start us
What
off?
was your
with?
answer?
So we all computed it to 2.
2.
Yeah. Did you get the same one, my friend?
No, I haven't had a chance to study the chapter.
Oh, no worries, man. Did you need us to kind of go over it a little bit with you, or?
No, it's okay. I will.
Yeah. Okay. No worries, man.
We'll catch up later.
Not a problem. No worries. All right. So then
Yeah.
we'll just. Yep. Oh, go for it, Wendy.
Number 4.
Yeah.
The
Awesome.
probability of obtaining a test statistic greater than Jordan's test statistic is 0.0403. Using this probability to determine the p-value of Jordan's hypotenuse test.
Okay. Probability of obtaining a test statistic greater than Jordan's test.
I'm gonna write the comment here. That's okay.
Oh, could you repeat that again, Quentin? What'd you say?
He's gonna write a comment.
I mean, I'm gonna write the comment just to hear it.
Sure. No problem, man. All right. So I'll be completely blatantly honest. I actually am not too sure about how to do this one. Completely honest.
Neither am I.
Yeah. All right.
Do we have to go like an old equation and find the p-value?
Yeah, that's what I was thinking. Like, I don't like it is basically telling us that it's Jordan's test statistic is 0.04403. Use the probability to determine the p-value. And that's weird because I guess that's the probability, right? And if we use the probability applet, like when you just punch that in and you find the z-score, I mean the test score for this one. Yeah,
See, and I
but
put the t probability.
yeah, the t
I-
probability. Yeah.
I put 2 in at the bottom. I shaded to the right because it was everything above it. Oh, greater than right.
Yeah.
And then I put with a degrees of freedom 8 because it's n minus 1.
Yeah,
And
that's
the
right.
area is the 0.0403.
Yeah, just a sec. Maybe I'll try to get to the same thing. I mean, I did see like sort of an equation. I mean, inside of like the test. I mean the lessons, lesson number 12. But I'm gonna actually try your way because I actually have no idea. So I'm gonna do the same thing. Yeah. I am pretty much clueless on this one. Where's the probability applet? Which lesson is the probability? I mean, the t-score applet. Is it lesson 9?
I always find it through the main page.
Yep, actually, you know what?
Okay.
Yeah, that's the smarter. For sure. All right, that's good. All right. Okay, got it right here. So we have 9, which is basically the degrees of freedom. And then, sorry, man, we got 9, which is, what was the degrees of freedom that you had?
8.
Oh, you had 8, okay. 8 and, okay. And then you got for the t-score.
2.
You got 2, yeah, because you rounded it up. That makes sense. Okay. I mean, I'll show you another way that I was thinking of. if you go to lesson number 12, I'm not too sure if this would be it. So, do you know like where it's just right below when you know like when they did the summary of like the infection, like the nosocomial infections? I don't even know if I'm pronouncing that right, but just right below that, which is it says summarize the relevant background information in step 1. So it's kind of like in the middle of the page, and you go all the way down. And then it goes right at the bottom right there. It gives us an example. It says, answer the following questions. So it'll be the following question will be 13. So let's say, find the p-value and compare it with the level of significance. And if you go to show that, you kind of see that little formula right there.
Mm-hmm.
It shows p-value, and then it's the SING, two-tailed, divided by 2. So I was thinking that I may have to do something with the equation, because it's giving us a probability right there, right?
Yeah, look at number 12.
Number 12?
Right there. Where you says make the test statistic of p-value on the graph.
Yeah, that's right. Mark statistic. Oh, go for it, Wendy. Sorry. My bad.
Well, it just says like in that, like the value of the p-value is this. Is the 5 point whatever on the horizon axis with only a tiny area to the right shaded, and it says it's the same thing. So is the answer 2?
Yeah, that does make sense. So you're thinking that would be the answer for that one, eh?
Yeah.
That makes sense. And then you just said it would be 2, right?
I think so.
Okay. Find the p-value.
Anybody else?
I guess we're all in the same. We're trying to figure it out. Yeah. No worries. All right. Not a problem. Hey,
I put 2.
You put 2? Okay.
I'm putting 2.
All right. All in favor, we'll keep it at 2, I guess.
Or is it the area? Oh, I don't even know.
Yeah.
Let's move on to number 5.
Sure, we can definitely do that one for sure. This one seems like it'll be a little bit easier.
Hopefully.
Because I was able to kind of do a similar question to this one. I kind of took a look at it, so I think it should be good.
Perfect.
All right. I mean, that's what I was confused with, because I'm not too sure. Maybe 13, we'd use that equation. It'd be because like it says that we do have the probability of the value, which is 0.0403. So I was thinking is that you just rearrange the equation. So you would do is that you have the p-value, right? But you're looking for basically the significance. So you just do 2 times by that value. But anyways, we're gonna move on because we have no idea. But we'll set it for 2. Okay. All right. So I'll actually Clinton, would you like to read the next one, my man?
Yes. Right. No. Sorry. Use the data to answer your next question. Perform a sample in SPSS for that one test. Make sure that the test 1 minus 1. Use an hypothesis. What is the test? I got 0.7.
Awesome. All right. I'll do the same. I'll try to cut that up right now. Okay. It's going to open up the Excel. There we go. All right, copy and paste both of the group 1 and group 2.
Did you get 0.407?
4070.
Okay.
And it's asking us for the test score. Yep, I got 0.407. Is that what you guys got?
Uh-huh.
Yep, perfect. All right. How about everybody else? Everybody got the same answer, or?
Yes.
Yep. Bueno. All right. What is the p-value? All right. And what is it looking
I have 0.89 or 0.689.
All right.
Yes.
My bad. I just had to change the significance level. Forgot to do that. All right. So what did you guys say you got?
0.689.
Yep. Okay. Yep. That's what I got too. Perfect. Yep. I was a little confused there. Just like, yep, that's a negative. So obviously you have to put it in decimal form. All right. Good. All right. All right. So question number 7. Kim, would you like to read that one?
Okay. What is the correct decision based on this evidence?
Okay. So this one, so significance level is 0.10. So it would be fail to reject the null hypotenuse, is that correct? Because I believe since the p-value is greater, they would fail to reject it. Actually, I'm going to take a look at that. What do you guys?
Reject the null hypothesis.
Oh, it says to reject it, eh?
No, it's fail.
Yeah, fail to reject. Yeah, that's right. Yeah, because it's greater than 0.10.
Right.
Yeah, that's right. All right. All right, Stylen, would you like to read the next one, my man? I'm sorry if I'm pronouncing your name wrong, my friend. I can be terrible at names sometimes.
Okay. Suppose your alternative hypothesis is instead HA major or greater than 0. What is the correct decision based on this evidence?
Okay. So I'll do that right now. So greater than. Suppose your alternative hypothesis instead of A. What do you guys think for this one? What would be the answer?
The first one, I think.
Yeah, we have insufficient evidence that the mean of the difference is equal to 0. Yeah, yeah. Because I guess you choose that one because like it's only if basically if you're if it's below the level of significance, right? And since it's above it, it is equal to 0. Is that correct?
Mm-hmm.
Yeah, that's what I
Is
think
it?
too.
It's not the third one, is it? Because it has the greater than sign in the hypotenuse. Whatever.
That is a
That
good
makes sense.
question. No, that makes sense. I'm not completely sure. Maybe if I
I think the first one because we are rejecting the null hypothesis that is equal to 0.
Oh, okay.
Yeah. I believe it would be
So
that way too.
if the p-value was greater than the level of significance, we failed to reject. So because we have insufficient evidence, the mean of difference is equal to 0.
Yeah, because I think I remember reading that too. Like instead of the lessons, it said like, since you failed to reject it, that it just equals the same because the null hypotenuse is supposed to remain the same.
Okay.
But I could obviously be wrong too, but I'm pretty sure that's it.
Well, if I get it wrong, I'm switching my answer.
Yeah, that's right. Awesome. We'll see what happens at the end of the day.
Exactly.
All right. Okay. All right. So I guess we'll go for the next one. All right. Kim, would you like to read that one?
Okay.
Awesome.
Use the data file chapter type data B1 to answer the next 8 questions. Perform a current sample T testing in SPSS. Be sure that the test is group 1 minus group 2. This data comes from nosocomial. What is that? Infectious access. The null hypothesis is this equation. The alternative hypothesis is this equation. And the level of significance is equal 0.01.
Awesome.
This is greater and or yeah.
Okay. All right. I'm just going to have to pop that up. Okay, copy.
I have the second one, the DF one.
And
I got
Yeah.
it.
Yeah, I believe it would be N2 because it's 22. But
Hey, it's greater. You are right. Guys, I've looked at so many numbers today.
oh, no worries. Hey,
so remember the formula for that is n minus 1. I mean, where are you going?
That's right. That is right. Because DF is, yep, kabam. Valid statement, kabam.
Good job.
All right, what is the p-value? It's all good. There's so many numbers too, Wendy, so hey, I could always be wrong too. What is the p-value? So it's not saying it's equal to, yeah, okay. So it's not saying if it's greater or less. So this be not equal to. I'm just going to put this in my calculator. So I got 0.001.
Yes.
Yeah? Okay.
Yep.
Perfect. Awesome.
What decision do you make? Reject or fail to reject?
Okay.
Reject.
Reject.
Yep. All right, so question 12. You decide to try an alternative hypotenuse. This time you use HAUD. I believe this is greater, right? Or is it less?
Greater.
And greater. Okay, good.
That's greater.
Awesome. I always get confused with that. I always have to double check. And you keep the same level of significance. Did the p-value increase or decrease? All right, so we're just going to switch that to greater. So it decreased. Correct?
Yep.
Correct.
Yeah. All right. There we go. What decision do you make? So this, since it decreased, it's still going to, you're going to reject it still.
Mhm.
Yeah. All right.
Reject.
Yep, reject. All right. All right, Clint, would you like to read the next one, my man?
Based on your response from the previous question, what conclusion do you make?
Okay. We have sufficient evidence that there is no main difference between the groups. Insufficient evidence that there is no difference between the two groups. I think it would be the third one. We have sufficient evidence that there is a mean difference between the two groups. Maybe I'm wrong. Hold up.
Third one is right.
Yeah, you think that's right? Oh, yeah, because
Yeah.
I believe there would be, because both, we rejected the null hypotenuse for both of them, right? Yeah. Everybody agree with that? Yeah. Awesome. Okay. The next one. All right. As we have seen, the p-value depends on the internal hypotenuse. In general, which alternative hypotenuse will be given the smallest p-value? Will it be hypotenuse is equal to, hypotenuse is greater, I believe that's greater, and the last one, hypotenuse is less, or not, ends.
Small list.
I'm just going off of the last one. I'm assuming it's the last one. So it's greater than 0. Less than 0. So not the last one. It's the second one.
Agree?
Is this thing on? Are we working? Is there anybody there?
I think it's the last one also.
You think it's the last one?
Wait, I thought it was lesser than 0 though.
It is less than, so it's the second one.
Right.
Yeah.
And I'm back. Sorry, guys. Got disconnected.
You're good.
Got disconnected. Did you guys figure out for that one? Question 16? Or we're still kind of trying to figure it out?
16, we're on 15.
Oh, you're on 15.
Yes, I think it's B. There's not
Oh,
a B
wow.
there, but I'm pretending it's B.
Yep. Okay, so 15 is B. Okay. All right. All right, so 16. What is the point estimated for 95 convenient interval? So this one I was a little bit stumped on. All right, I'm gonna have to read. Convenient. Interesting, but isn't it supposed to be plus or minus?
Yeah, but I think it's 6.652.
0.652. So how did you get that one, my friend?
I noticed from previous assignments that the Excel tool we are using to give you the confidence intervals. If you minus the mean from one of those numbers, it will give you the same amount. So it's exact same. If when you calculate M, it will number. So what I do is just do go say the mean minus the confidence interval, and I get the number.
Very cool. Okay. So what you
What
did
was your
is
number again?
6.652. Sorry.
No worries, man. Not a problem. All right. So I guess I believe it could be that. I think are we good with that question, guys? Yeah. All right. So what you did, you good? All right. So
So if you go now, for example, the next two questions, you will figure out that if you add to the mean that number or minus that number to the mean, you will get the lower and the upper bound for the interval.
Oh, so the 0.652 take away from.
Yeah, that would be a test to figure out if the number was right or not.
Okay.
Okay, so 17, the margin of error, did we get? Just kidding. I didn't calculate this all the way.
Oh, no worries, me either. Not a problem. All right, so it would be 1.96 times by the standard deviation of that? No, no, yes, no. And
No, it's just standard deviation divided by the square root of n.
Yep, that's right.
Okay.
That is correct. Square root of n. All right, I gotta calculate that right now.
$3.197.
Just a sec. N is going to 15.
Oh, I didn't times it by 2.
Oh yeah, that's right.
Right,
Yep.
snafu.
Oh dang, yeah, that is right. You times it by the t-score instead of the. Wow.
Mhm.
Yep. Interesting. So you want times it by the 1.96. It would only be the t-score instead of the. Yeah, that's right. That's what was messing me over. That makes sense. Thank you. That helps out a lot.
So where are we? 16?
Yeah, we're all trying to figure.
17?
7. Yeah, we're on 17. Yeah.
Did you get 11?
I think. Sorry, I said 6.652. I was talking about 17.
Oh!
Sorry.
Oh,
So
you're
what did you
saying.
get on 16?
Yeah, what did you get for 16?
I think it's 11.955.
The mean.
Yeah.
Okay, that makes sense. All right. Legit.
Sorry.
No worries, man. That's not a problem at all. No worries. Okay, that makes sense then. I was just gonna say, man, you're genius. I'm just like, man, how did you do it? But hey, you're good, man. You figured it out. I actually had no idea about that question too. So there you go.
Okay, okay, but no, 18, did you get 5.303?
Yeah, I believe it would be that because that's the confidence interval for
The lower.
lower. Yeah.
And then the next one would be 18.607.
Yes. That's what I would believe. So for the for number so for number 17, did you guys get 11.953 or am I completely off for the margin of error?
16.
Got 16. So I definitely messed that up.
11.955.
Was for 16. Yeah, that's for 16. So 11.9. And then for 17 you got
6.652.
6.652.
Yeah.
Okay. And you guys just did 1.7. So you did 15.003 divided by 22 square rooted. And then you times that by 1.96. Yep, I got it. Legit.
Sweet.
Actually, no, I didn't. I forgot. Okay. So how did you guys calculate for the margin of error again? So it was, would it be 1.96? And then that's all times by 15.003 divided by 22. That's square rooted.
Okay, then.
Is that how you guys came with that solution, or? I'm just trying to make sure I'm on the right track.
I was going off Stalin. Stalin. When he went the intervals, the upper and the lower.
The margin of error.
That's it. Is that right, Jordan? Yeah.
How I calculate the margin of error?
Yeah.
What I did is from the Excel tool, I go to I minus the mean from one of those interval numbers.
Oh,
and you got it.
Then that would give you the negative
easiest
order
way.
answer. That makes sense. So you just basically did that, and then it would be negative 6.652, or it'd be positive 6.652. Is that correct?
Exactly. Yeah.
Yep. Okay, that makes sense. Yeah, because I always thought when you were basically measuring for margin of error, what you would do is that you use this 75% interval. So it'd be the 1.96, right? And then you'd times that by the standard deviation divided by the number of sample square rooted. Is that correct? And then you'd probably get the same answer. Is that right? Yeah. All right.
Yeah. But
could you guys
from the Excel tool is easier, I think.
Yeah, because I think the Excel tool it's way more accurate than actually the when you do it the other way around. Because I remember actually I calculated that. That's why I was so confused. I was just like, dang, I keep on doing it on the calculator, but it keeps on getting it wrong. So I guess that's right then. Because like if you guys do it by the calculator, what would you guys get if you did it through the calculator? So what I got is I got 6.269. So that's what I got through the calculator. So I think that it's just accurate to do it through Excel then, because it is way off. Yeah, so that makes sense. Sweet. Thank you, my friend. I was confused about that one. Awesome. All right. What was that, Clinton? Did you
type the 19th answer? This is just breaking down here.
Oh, for what question, my friend? I'll type it up.
19?
18.
18 and 19. Okay. So 18 was... You guys can type faster than me. Hey, go ahead. For sure. There we go. Hopefully that makes sense. So I put 18, so it's 18 5.305, and then for 19 it's 18.607 for 18 and 19.
05?
So 18 is a 5.303. So that's for 18. Yeah. All right.
Question 4. Do we have any other ideas on that one?
Yeah, that's one I'm confused about too. I was actually just gonna mention that too. I mean, like, what I was thinking, it could be correct. I may be wrong, but if you go back into the lessons, like, it doesn't really distinctly tell you exactly what to do for that one. But if you go to all the way down, and it's the same place that I showed you, the 12 right there. It says make the test statistic and p-value on the ground on the sampling distribute. Sorry, number 13. So it says find the p-value and compare it to the level of significance, and that's just where you go answer the questions in the boxes. and then it has p-value equals significance two-tailed divided by 2. So what I would think is that you'd rearrange the equation because you already have the probability, right? So what you would do is that you would basically take the 2 and you would times it by that initial probability, and then you should get the answer. That's what I was thinking. But maybe. If I do it, I'll let you know if it works out.
Okay.
If that helps out. Because it's, yeah, I'm not completely sure about that one. What do you guys have any other guesses at all, or?
The question number 4. What was the answer?
Yeah, we weren't completely sure. We were thinking that it was either 2 through. How did you figure that one out again, Wendy? I completely forgot.
I just was going off of the one before, to be honest.
Yeah. Okay.
But I really think I'm wrong because the answer says down to the third decimal.
Three decimals. Yeah.
Yeah.
So
That's why I really think I'm wrong.
All right. Well, I think you could try it out my way if you want. I mean, if that one works, hopefully. Because I believe I'm just trying to figure out how they figured. I should have read further into the lessons. How did they figure out that 13 is the question?
Oh my god, that really possible, I don't think.
No, it doesn't. I mean, like, even I actually looked through all the different I looked through the worksheets and they didn't mention anything about that one. Unless I basically overread it, but didn't read through carefully. But I'm pretty sure you do 2 times by that value, and then you would get the the number you're looking for, the significance.
So 2 times the 0. Hold on.
Yeah, so it would be 2 times by 0. Yeah. So it'd be 2 times by. Oh, sorry. Go for Wendy.
No. So 2 times 0.0403.
Yep, that's correct. That's what I think.
So it'd be 0.081.
Yep, because you would just round it up.
What was the
Oh, number 8, you said?
Yeah.
Vincent? Yeah, so we did the first one. So it was, we have insufficient evidence that the mean of the differences is equal to 0.
Weren't we trying to on another one?
Oh, could you say that again, my friend?
Weren't we trying to that and another one?
Oh, similar to that question, there was another one. Oh, sorry, could you type that up, my man?
Were you asking to discuss another one?
Yeah, for that.
For that one.
The third one.
Okay. Just wondering.
Okay. And for number 8, we just basically stated we have insufficient evidence that mean is different. Yep, never mind. We're good. Yeah, question 8, we did the first one. Is that correct? Yeah. Okay. Okay. Well, guys, we can continue. Is there any other questions you guys want to talk about, or like the homework at all, or? Yeah, I'm down for staying if you want to figure out more. Up to you guys. But if we're good, then we'll hand her in and we'll see what happens. You always have a second try.
You do.
Yeah.
Yeah, that's right. Okay. Well, if you guys are all good, so is everybody good or? Yeah. All right. Awesome.
Good.
Awesome. Way cool. Well, hopefully it all works out for us. But anyways, we're still good for on Thursday, right, guys? At 6 p.m. Yeah, 6 p.m. Yeah. Awesome. All right. Well, I shall see you guys then. I hope you guys have a good rest of your week. If you guys have exams, good luck. For sure.
All right, you too.
Okay.
All right. They take care, guys.
Bye-bye.
Bye.
Bye.
Bye.